Hello, lovely people. I hope you are doing well and that all is auspicious. Here we have a question on functions. So, it's an exam question. The functions f and g are defined by f of x is 2x plus ln of 2, that's the natural log of 2, or log to the base e of 2, where x is a real number, that's the domain given. And g of x is given by e to the power of 2x, again, where x is a real number. Part A is asking us to prove that the composite function of g of f is given by this. Okay, let's see if we'll have space to do it here. Right, I'm going to try and squeeze in this little space here. We'll see. Will I be successful? We have g of f of x, so we're putting in f into g. So that's going to be e to the power of, so g of x is e to the power of 2x, but instead of putting x, I'm going to put f of x. Okay, that's what g of f of x is. And that equals e to the power of 2 times, well, f of x was equal to 2x plus natural log of 2. Okay, now expanding this bracket in the index or in the exponent, we get e to the power of 4x plus 2 natural log of 2. Okay, there's a lot more manipulation that needs to be done. We can say this is e to the power of 4x multiplied by e to the power of 2 ln 2. This is just using rules of indices, right? You're multiplying these things, that results in the addition of the indices. So we can go backwards. If you've got two indices that are being added, we can rewrite it as the product of the two separate bits. Okay, then that becomes e to the power of 4x multiplied by, look at this, we can use our log law to rewrite this as e to the power of ln 2 to the power of 2, so that 2 comes up there. Okay, looks like I'm not going to have enough space, but it's all good. You know, I saved a lot of space. So this is part A continued. That becomes e to the power of 4x multiplied by e to the power of ln of 4. Lo and behold, e and ln are inverses of each other because ln is log to the base e, so they're going to cancel. So you have e to the power of 4x multiplied by just 4, which equals 4e to the 4x. There we go, 4 marks. Thank you very much. Part B. In the space provided on page 19, sketch the curve of y equals g of f of x and show the coordinates of the point where the curve cuts the y-axis. Okay, so g of f of x, as we know, is 4e to the 4x. Page 19 is over here. So we have g of f of x is equal to 4e to the power of 4x. Just to do a sanity check, I'm going to check that. Yep, 4e to the 4x. So I can see that this is just a transformation of an e to the x graph. So if I just draw a little sketch of an e to the x graph, nothing too fancy, that's that there. I can now use this to think about how my e to the power of 4x graph might look like, and then 4e to the power of 4x. So here, with an e to the x graph, of course, I'm going to have this shape. And the other special thing is that it crosses the y-axis at 1. So the coordinate here is 0, 1. So that's it. Now, if I were to draw e to the power of 4x, well, that's going to divide all the x coordinates by 4. So you're still going to have the same shape. And if in this case, the x coordinate was 0, well, 0 divided by 4 is still 0. So it's still going to be 0, 1. Okay. And then if I apply the multiplication by 4, all the y coordinates get multiplied by 4. So here, so this is e to the power of 4x. There isn't really much of a difference looks-wise. Maybe it's a little bit more compressed, but that's it. where this crosses the y-axis, well, if all the y coordinates are being multiplied by 4 as a result of doing 4 e to the 4x, then this 0, 1 becomes 0, 4. So my final sketch over here is going to look like this. So I have the same kind of shape, and my intersect here is going to be 0, 4. Just to verify that, where we have a y-intercept, that is where x equals 0. I don't know why I did that. That was just not needed. Hey, there we go. Yeah, that's where x equals 0. So if I substitute x equals 0, I have 4 e to the power of 4 times 0, which equals 4 e to the power of 0, which equals 4 times 1, because e to the power of 0 is 1, which equals 4. Let me just check that I've answered the whole question. That's it. Just show the coordinates of where it cuts the curves, where it cuts the y-axis. Next question is to write the range of g of f. Well, part C is quite nice actually because it leads on from this graph. Usually when you've got a graphical representation, it makes it much easier to see what the range is going to be. We still have this asymptote of the x-axis, or the line y equals 0. So it was g of f of x, right? Let me just check. Yep, the range of g of f. So g of f of x is a real number, and g of f of x is greater than 0. That's it. Because if we look back at our e to the power of x, the range of that, i.e. kind of like the y values, the range is it's a real number greater than 0. If you do e to the power of 4x, well, that's not going to change the range because the x values are what's changing. The y outputs are still going to be it's greater than 0. If you times everything by 4, a quantity greater than 0 multiplied by 4 is still going to be a quantity greater than 0. So we have that it's just greater than 0. And then part D, what are they asking us for? Find the value of d dx of g of f of x equals 3, giving your answer to 3 significant figures. So we need to differentiate g of f of x. We need to differentiate e to the power of 4e to the power of 4x. So the derivative of 4e to the power of 4x, and we want that to equal to, what was it they said? They said 3. Okay. So firstly, differentiating this, well, that's going to become 4e to the power of 4x multiplied by the derivative of the 4x, which is 4. Okay, that's differentiating that, which is equal to 3. Okay, so now we have 16 e to the power of 4x, just doing the 4 here times the 4 here, which equals 3. Then, dividing by 16, we get e to the power of 4x is equal to 3 over 16. Then, to get the 4x by itself, we take the natural log of both sides. So we have 4x is equal to ln of 3 over 16. Then divide by 4. We get x equals ln of 3 over 16 all over 4. That's our exact answer. The question says give it to 3 significant figures. So wax out the calculator. Ln of 3 over 16 over 4. And that gives us, drum roll please, minus 0.418. And that's the 3 significant figures. Thank you very much. That is it for this video. I will see you in the next video with another question. Take care.